If you remember from your early algebra days, you probably spent some time writing equations for linear functions when given maybe 2 points of data for that equation. So we're going to take a similar approach here. And in this example, I'm going to provide 2 data points, and we're going to understand that the relationship between those 2 data points is exponential. So our job will be to build the exponential equation. So let's go ahead and walk through this step by step here. So our goal is to find an exponential equation. So we understand that's the relationship between the points. Exponential equation that passes through, and I'll just give us 2 points. So an equation that passes through the points 2, 0.8. How about that's one of the points we're given. And then our second point that we're given will be 4, 3.2. So without me telling us that we want to build an exponential equation, we might not know that that was the correct route to go, right? If you're just given 2 points of data, you could assume a linear relationship. So it's because I indicated that there's an exponential equation that we need to approach this a little bit differently. So we were given 2 points. I'm just going to try to walk through this in a way that feels clear. So I'm going to label my first point as an x and a y, right? And then same thing for my second point. So I was given 2 x's and 2 y's. And we know the general form from the last video of an exponential is y equals ab to the power of x. So all I'm going to do is set in the given xy pairs into that general form. So I'll color code so you can see what I'm doing. So if I plug in the green ordered pair into that general form, I'm going to plug in 3.2 for the y value. I'm going to plug in 4 for the x value. So that is taking this 0.4, 3.2 and plugging in my y and my x into the general form. I'm going to do the same thing with the other pair, 2, 0.8, and then we're going to do some kind of weird algebra. So if I do the same thing for the second point, I'm going to plug in 0.8 as the value for y and 2 for the value of x. So again, how I got that was I just used the given xy pair of 2, 0.8, plugged in the 0.8 for the y and the 2 for the x in the general form of an exponential. So we're just plugging in our given data. Now, again, there are different approaches, but what I'm actually going to do, something that may feel a little new and unfamiliar, is I'm just going to divide the 2 equations I just wrote down, shown in green and yellow. So I'm just going to say divide the 2 equations. So you guys are familiar with, you've added, subtracted, multiplied. So it might feel a little weird to divide, but the result that we get will allow us to determine one of the values, right? Hopefully it's clear from this general form that we're seeking to find a value for A and a value for B in order to have an exponential model for this data. So on the left side of our equation, currently where I'm dividing these 2 equations, I'll just rewrite it so it's clear. I'm doing 3.2 divided by 0.8. And I'm setting that equal to ab to the 4th divided by ab squared. So 3.2 divided by 0.8, that's basically 32 divided by 8, so that sounds like 4. And then on the right side, the a's divide out, and b to the 4th divided by b squared, remember, just think literally about what exponents mean. And we understand that that's going to leave just 2 b's in the numerator, right? Because some of the b's cancel out top and bottom. So that just leaves b squared on the right-hand side. We're very familiar with solving quadratics like this. We've done this quite a bit. So if I square root both sides, I would get back plus or minus 2. From our first video, we understood b, by definition, will be any positive real number not equal to 1. So even though through algebra I would get back plus or minus 2 for the value of b, using our understanding of the general form, I'm only going to take the positive 2 here. So our value for b looks like 2. So that's good news. We're definitely on our way to building the general form of the exponential equation. But now I need to solve for the other placeholder, which is a. So far we just found the value of b in our model is going to be 2. Now our question is, all right, then how do we figure out a value for a? So let's just use another one of our given points. Again, you can take your pick. I'll just go ahead and use the point, let's see, I'll use the green point. So I'll use 4, 3.2 to demonstrate this next step. So now that we found b, I'm going to show some steps to find a. In our general form, y equals ab to the x, we can start filling in our model as y equals a, and I'll just highlight a is currently unknown, times 2 to the x, because we just found from our previous step that b has a value of 2. So I'm going to use the given data. I mentioned I was going to use that point that said, let's see, what was that point? That was 4, 3.2. I'm going to plug in for y, 3.2. I'm going to plug in for x with 4, and that will definitely be enough to solve for my last value, which is just a. Okay, so 4 went in for the value of x, 3.2 went in for the value of y, and then we're just going to carry out the necessary solving steps to get a alone here. Okay, cool. So we've got 3.2 equaling 16a, right? 2 to the 4th is just 16. So dividing both sides by 16, we will find the value of a to be, let's see, 32 divided by 16 is 2, but we had 3.2 divided by 16, so that would be 0.2, if you're okay with decimals. So that would be the value of a for our exponential model. So to put it all together, our equation that has the form y equals ab to the x will be y equals 0.2 times 2 to the power of x. And that would be the exponential model for the 2 data points we were given at the beginning. So that'll be a helpful example for some of your homework and even your project. Hopefully that makes a little bit of sense, and feel free to graph this too. If you graph the equation we just built, you will be able to find the 2 given points on that graph. So have some fun with that.